In order to understand machine learning and deep learning from the very bottom up, one of the foundations is math, so mathematics, which is why I want to start doing practice exercises in. We'll start with algebra and then we'll probably go into maybe linear algebra, and we'll start with very like simple concepts, and as we go through we'll probably progress into more advanced concepts. So right now I'm actually into the Brilliant app. So this is the Brilliant paid app. It's like $10 or $12 a month, and it's probably one of the best investments I'm actually uh, investing in every month. So aside of YouTube Premium, which gives me learning experience with no ads, because there are a lot of videos, webinars, conferences, and the courses that I'm doing on YouTube. So it's probably one of the best investments. Also, Brilliant, and I think Duolingo is the third one. So these are probably my top three investments. So when it comes to Brilliant, oh man, there's a lot of courses in here. So currently they have 60 plus courses, and aside of the courses which are amazing in of themselves, they also have practices, and they also have a very big community of problems, which I think these problems are posted daily, and maybe we'll be looking into some of these problems as well at some point in the future. But now let's start with algebra and expressions and variables and algebra warm-up. And let's start with cryptogram. So cryptograms algebra warm-up. First one. So what do we have here? In this cryptogram C and D, let me actually see how this works. Maybe let's take green. Okay, so C plus, so we have C, let's actually do blue. We have C plus CC equals D4. Now in this case, C would be represented by one digit and D would be represented by another digit. So what combination for C plus CC would give us D4? In this case, if you just one of the approaches is to substitute from the list of multiple choices. You could try to substitute each one of them and see if you get a valid result. So in this case, if we use 2 as a solution, in this case it would be 2 plus 22, and in this case we'll have 4, but in this case we'll have 24. So this cannot be right, because if C is 2, D has to be something different. So D cannot be 2. So in this case, the solution doesn't work. So it's not 2. Now, following the same rationale, we could substitute with 4. In this case, it would be 4 plus 44. It would be 48. Still, we wouldn't have a different D. So in this case, C would be equal to D, and the solution would not be right. If we do 7, in this case, we have 7 plus 77 equals 84. So 7 plus 77 is equal to 84. Now, in this case, this is the valid solution. If we do 9, we have 9 plus 99, it's 108. So in this case, there is no 4, so this is not the valid solution. So our valid solution in this case, as we can see, is 7. All right. And that's the correct one. Now let's move on. In the same rationale, we have 1b plus b6 equals 71. If we replace b with 1, we have 11 plus 16. In this case, we have 27. So it's not 71. That's not a valid one. Now, this is one approach, but and this is probably not the best approach that I'm actually using, by taking from the multiple choices and actually replacing it here. There might be other approaches, but this is kind of like a hack. So if we replace, if we use 5, we have 15 plus 56. So 15 plus 56. And in this case, we have 71, which is our correct answer. So we'll be selecting 5. Now, if we do show explanation, we can see that looking at the column, we have b plus 6 ends in a 1, so we must have b equal to 5. So their explanation is not actually like step by step, but it's also a deduction, since they're saying that we must have b equal to 5. Checking the rest of this cryptogram, we verify that 15 plus 56 equals 71. Okay, moving on. 3x 7. So 3x 7 equals 41. What number in the 30s, if being added 7, is equal to 41? Now, you don't need a lot of brain to actually do this. We have 34 plus 7 equals 41. And the explanation, it's so of course for each of these problems there might be multiple solutions. Now in this case they have only shown 2 solutions. We have 3x equals 41 minus 7. That could also be the case, because you can just this could be simpler. You can just subtract 41 minus 7 and you get 34, and you have the solution x equals to 4. However, you can just do what I did, which is basically the same thing, but I'm not subtracting, I'm just adding in the memory. So in my memory is what number in the 30s, if added 7, is equal to 41, and that is 34. Okay, let's continue. This one, 1e times, so what number? In this case, we have a multiplication. 1e times e equals 9e. So all of these e's are actually the same digit or the same number. It could either be 0, 1, 5, or 6. But in this case, it cannot be 0, because 10 times 0 is 0. Okay. it cannot be 1 because 11 times 1 is 11. So it's not 1 either. What about 5? 15 times 5 equals 75. So it's not 5 either because it's not 95. Okay? Now, of course, if it's not 0, 1, or 5, then it probably must be 6. Let's verify this. 16 times 6 equals 96. So in this case, the answer is 96, and the answer actually E equals to 6. All right. Okay, so it's 96, and we have the correct one. Okay. And there's another one. 2a times 4 is 6. This is another easy one. So we could either do what number in the 20s divided, multiplied by 4 equals 96. And that's simple. 24 times 4 is 96. But we can also do the reverse. So what number? We can simply do 96 over 4, and in this case we have 24 without actually doing the entire subtraction, the entire division here. So 96 divided by 4 equals 24. And there you go. We have the first quiz finished, the cryptogram algebra warm-up, and then I think we'll be finishing this video here, and then in a future video we'll do the exponents warm-up.